So we're going to look at polynomials and the distributive property in this review section. So first of all, before we can start reviewing, we need to look at some terminology. What exactly is a polynomial? Well, the first thing, if we have a single term, a number, a variable, or a combination of those two, this is called a monomial. Mono meaning one. So the variable is the letter, a coefficient is a number. We could have just a coefficient, just a number, just a variable, or a combination of the two, and that's called a monomial. Now, if we have more than one monomial added together or subtracted, this is what's called a polynomial. And we're going to deal with lots of different polynomials in this section. So, polynomial, couple properties. One, it has variables and coefficients. Doesn't necessarily have to have both, but it has both of those in there. And the exponents are always whole numbers. So the exponents on the variables are always whole numbers. So we're going to look at polynomials and what we can do with them. If we have polynomials, and sometimes we have a polynomial that has the same variable, what we do is we call these like terms. And if we have like terms, then we can add or subtract them together. This is combining like terms. So if we look at this polynomial, we have 3x and a 5x. The variables are the same, so we can combine like terms. And when we combine these together, we're just doing the operation. 3 plus 5 gives us 8x. Now, if we have more than one variable or more than one like term, like in the second example, we have a negative 2x and a negative 3x, we can combine those like terms. And we have a 4y and a 7y, we can combine those like terms. And if we combine those like terms, we're going to get negative 2 plus negative 3 is negative 5x. That combines all the x's together. And if we look to combine the y's, 4 and 7 gives us 11y. Now, like terms don't necessarily have to be different letters. They can also be different powers or have different exponents. And that's what this next example looks at. We have 5a squared, 6a with an imaginary exponent 1, 2a squared, and 10a, again with an imaginary exponent of 1. So we can combine together everything that has squareds and everything that has the imaginary exponent 1. When we do this, we're going to get 5a squared minus 2a squared. Those two we could combine together, and we could have negative 6a plus 10a. We can combine those together, and when we combine 5a squared and minus 2a squared, we would get 3a squared, and negative 6a plus 10 is plus 4a. So that's combining like terms, also known as adding and subtracting polynomials. Well, let's look at some bigger polynomials. We have 3 terms in this case, so it's called a trinomial. And to add these polynomials together, it's the exact same thing, combining like terms. Now, it's probably better just to rewrite this without brackets. Now, in this question, the brackets are doing absolutely nothing. So, this is the same as x squared minus 4x plus 7. And this plus, we just can get rid of the brackets, plus 3x squared minus 5x minus 10. Now I'm going to show you a little technique that's easy to not lose your like terms when you do the combining. We're going to combine the x squared terms. We have a 1x squared term and a 3x squared term. When we combine those together, we get 4x squared. Now, once I've combined them together, I'm just going to put a little slash through those to know they have been combined. Now we have negative 4x and negative 5x. When we combine those together, we get negative 9x. And I'm going to slash those to know they're combined. And the last two like terms are these variable, or these coefficients, these constants that don't have any variable. We have 7 minus 10 is minus 3. That's all we do to add polynomials. What about subtracting? Too far. Subtracting polynomials. Well, if we subtract polynomials, it's a little different. This negative sign in front of the bracket does change all the signs on the inside. Remember, that's like having a negative and we're subtracting each one of these. So what I'm going to do is I'm going to drop the brackets first and take into account that subtraction sign or that negative sign outside the bracket. So 5x squared minus 2x plus 13. And now we're going to subtract 3x squared, subtract negative 9x, and subtract 8. Now, when we subtract a negative, right here, that's the same as addition. So we can just make that plus. And now we do our same thing we did before, combine our like terms. First two are the x's, or sorry, x squareds. 5x squared minus 3x squared is 2x squared. Those are combined. Now we're just going to combine the single x terms. Negative 2x plus 9x is plus 7x. Those are combined together. And we're last 13 and negative 8. When we go 13 minus 8, we get plus 5. Those are combined together. And that's how we would subtract polynomials. What about multiplying and dividing monomials? So if we have two terms and we're just multiplying or dividing them, what do we have to do? Now we have to remember our rule for exponents. If we have exponents, the numbers just follow the rules for multiplication. It's fairly straightforward here. If we have 3x squared times 7x cubed, the first thing we do is we multiply 3 and 7, giving us 21. And then we multiply x squared and x cubed. Remember, if we are multiplying and the base is the same, we add the exponents, and we get x to the 5th. Well, what if it gets a little more complicated? The rules don't change. We still start by multiplying the numbers. So the coefficients here are negative 8 and 7, so we're going to get negative 56. A, there's no other a's in there, so we can't add any exponents, so we just have a single a. We have a b here and a b to the 4 here. And remember, the exponent on b, if there's nothing, is a 1. When we combine those together, we get b to the 5th by adding exponents. And again, c has an exponent 1 times c squared is c cubed. That's how we would multiply monomials. Well, what if we're dividing? It's the same as dividing fractions, which we've already reviewed, and using our rules for exponents, which we've already reviewed. First thing we do when we're doing division, though, is we separate it. We are just going to look at these numbers, 24 and 6. If we go 24 divided by 6, we're left with just 4. Now we have m to the 6 on the top and m1 on the bottom. We subtract our exponents. 6 minus 1 is 5. And now we have n cubed on the bottom, n squared on the top, leaving us with n to the negative 1. And remember, if we have a negative exponent, we always want to take the reciprocal or flip it over. So we're going to have 4m to the 5th all over n. That's how we multiply and divide monomials. What about multiplying? What if we have a polynomial, more than one monomial, and you're multiplying it by a monomial, a single term? Well, this is where we have to use what's called the distributive property. Very, very important property in mathematics, this distributive property. Distributive property, what that means is we multiply everything on the outside by everything on the inside. We distribute it in. So let's go through and look at the first example. If we have 2 on the outside and a 4a, when we do the first multiplication, this distributes in, and I'm going to do this in 2 steps. It's going to be the same as 2 times 4a, 2 multiplied by the first term, and plus 2 times negative 6, which leaves us with 8a minus 12. Now, if you can do that in 1 step, great. If you need to take 2 steps, that's fine too. So that's if we just have a number or a coefficient. What if we have a coefficient and a variable? Well, it's the exact same thing. It's all the same multiplication. We multiply the numbers together, then the variables. Numbers, then the variables. So the first one, negative 3 times 5 is negative 15. X times x is x squared. Distribute it to the second one. Negative 3 times negative 8 is plus 24. X times y is just x, y. So that is the distributive property. Very, very important. And that is our review of polynomials and the distributive law.